Hey guys and gals, welcome back to another installment of the Skunkworks M8 versus Twin Cam Build series. Now, what we're going to do today is show you just some of the components that are going into the M8 build and kind of compare them to the factory components. Now, throughout all of this, I'm going to reference all of the videos leading up to this one that goes over each component in detail. So if you want more information on that, be sure to check out the previous videos. So let's get started on a few things. Let's start out with the bottom end here. Of course, this is a factory M8 case. You can see the rods are considerably different. Dark Horse Crankworks did this flywheel assembly for us. We've done the Timken bearing conversion on it. The flywheel has been plugged, balanced, trued, welded, and has less than 1/10 of a thousandths total indicated run out. This crank is perfect. So let's compare to the stock M8 rods as we did on our previous video with Dark Horse Crankworks. You can see, this is a true H-beam rod with taper top, or excuse me, a square top rod here. You've got a lot of extra oiling holes in here to keep your wrist pin lubricated. And of course, we've got a bronze bushing in there that has been honed to perfection. And if we compare them side by side with the stock rod, we can see there's a considerable difference here. Tapered top, no oiling holes, no bushing, and just a much weaker rod in itself. So the crank is ready to go. Also, in one of our previous videos, we talked about cylinders. Be sure to check that one out. So if you remember, we talked about some of the issues that have been common with the factory M8 cylinders being bored to 4 1/4 with the cracks there and how it's made. So we're not using the stock cylinders, we're using these. You can tell the liners are considerably thicker, and then of course how it's made there. This cylinder's been plateau honed, and it has been fitted to within 1/10 of 1,000th over all axes. So perfect hone on the cylinder. Next, we get into our forged pistons for the M8. They're ultra light but ultra strong. All right, now this engine, we're setting this one up to yield us a 10.8 to 1 compression ratio. He does a lot of touring. He rides with his wife on the back. So, and you never know what state he's going to end up in, what type of fuel he's going to have. So keeping the compression down just a little bit, he's not really going to lose anything for power because we're going to tune it 2 different ways. One, because he's using a power vision, it's easy for him to be able to switch maps. So we're going to have an aggressive tune in it that's just for him with higher octane fuel. And then we're going to have a more conservative tune where we lean it out a little bit for fuel economy. And then we also pull the timing back just a little bit to avoid any detonation for lower octane fuels while he's on his trip. All right, next we move to the heads. This, of course, is a stock head. Again, see our previous video on comparing M8 to twin cam heads. One of the things I would like to point out, which is a common problem with the M8s, is you'll see that these valves, this one is off the seat just a little bit. The seat's in there crooked. And you can also see it here, and you've got a little excessive carbon buildup in that area there. This is not at all uncommon with the M8 heads to have valve seat issues. Also, it's a little dark, but you can kind of see in there basically the stock port design on the exhaust side and then on the intake side. There's a lot of opportunity for power in these M8 heads with porting and bigger valves. So we move on to our heads. Of course, you can see it's been completely decked with a phonographic finish. That ensures a really, really good seal to the head gasket. We've got new valve seats in it. We've got new bigger valves in it. And then when we look at the porting, you can see there, it's been fully CNC ported, flow tested, and then of course we're running Viton valve stem seals. We're running a much better spring and retainer with a 10-degree lock on that axle. It keeps that valve in there nice and tight. And you'll also see we're running manganese bronze valve guides in there, and the valves have also been nitride coated. So that helps. The nitride coating is essentially it's like a friction modifier, if you will. So some engines can get pretty hot. So by having that coating, it helps to reduce any varnishing from oil that can occur inside a valve guide. So that head is done. The next thing we're going with is a fueling vented dipstick. I really like the fueling dipstick simply because it has, it's a little tight. This has a valve in it. All right, so that helps to evacuate all of the crankcase pressure, yet not suck any back in. So instead of being a free breather, and of course it's filtered air. So you can run either a small vent here or run the entire filter on it. One works as about as good as the other, but the other great thing about it, it actually has a dipstick on it. So this is a fantastic piece to run. Now, he had some performance work done previously on the bike, so some of the components I'm going to show you were actually out of the original build when it came in. So I'm a proponent, you know, I've said over and over, money's hard to make these days. I'm not one just to dig into your wallet and tell you to spend a bunch of money. If you have good components that are already in it, we're going to test those components. We're going to check those components. And if they function as new, there's no need for you to spend the money and just buy new stuff. So some of these items you're going to see are being reused from his previous build. Now, of course, we're going to stick with S&S push rods on this one. They're great push rods. What I really like about the S&S push rods is the thread pitch on the adjuster. Really a lot, instead of using like a 24 thread per inch, you get a 32 thread per inch on that, and that really allows you to fine tune the bore of the lifter and really get the motor as quiet as you can. So that works out great. Of course, we're getting rid of the stock automatic primary chain tensioner, and we'll be replacing that with a Baker attitude adjuster. Now, there are a couple, I want you to get a close look here at the Baker unit. If you ever saw the original first versions of the Baker unit, it did not have this outer supporting piece here. So Baker added that, and that added a lot of strength to this piece. The other thing they did was slot the back here. In the earlier units, of course, you use the teeth adjusters here, but they didn't have that slot on the back. So this is a big improvement. It just helps keep it more stable. So this is a fantastic piece. We highly, highly recommend this. One of the reasons we recommend that, and one of the biggest issues with the automatic tensioner is it's actually on the slack side of the chain. So one of the problems is this thing ratchets up almost too tight. You could play dueling banjos on the primary chain for the most part. So by manually setting that adjuster with proper chain slack, we're preventing the chain from being too tight. Your clutch baskets aren't always concentric to the main shaft and the transmission. And then, of course, you have potential crank issues as well, where the splines are not concentric to the center bolt that hold the compensator in place. So when you have multiple circles that aren't concentric running at high RPM, it creates quite a bit of chain slap. When this ratchets up too tight and it pulls on that chain, you can actually start drawing the sprocket shaft on the crank and the main shaft and the transmission together. And over time, it absolutely destroys main bearings and transmissions. So by giving that chain a little bit of slack and adjusting it properly, we're actually saving the main bearing in the transmission and potentially the main bearing in the engine case. All right, so that's why we do that. This is one of the parts that he had previously had in the build, so we're going to keep it. We've got a fueling cam plate and oil pump. Fueling makes a great product for this. Of course, we've tested this cam plate and this oil pump. Everything works as it should. We've also measured each of the holes for the cam and the crank. We've checked everything on the gear rotors, so this cam plate is good to go and go back in the bike. We're going to be using S&S premium lifters. In this particular build, because of his riding style, as I said, you know, the big thing about our Skunkworks build is custom tailoring the build to exactly how you ride. It's not just about buying expensive components. It's pairing all of those components together. So he had a cam in it, but we're going to switch this cam over and actually run the Redshift 472. So again, he does a lot of touring, so this build in combination with how we've done the heads is going to produce an incredible amount of low and mid-range torque. But for those times that he's riding by himself and he wants to hot rod it a little bit, he can change the map real quick with his power vision, and that 472 is also going to complement from mid-range to top end and give him power virtually everywhere. So the next thing, of course, we can compare that to the stock cam plate and oil pump. Again, take a look at our previous video on cam plates and oil pumps. I actually did 2 of them on M8 versus Twin Cam. So again, you've got a cast aluminum piece here and obviously a much nicer precision billet machined one. And of course, all the other differences I went into detail on the previous video. So if you have questions, please take a look at that. Of course, there's your stock push rod, stock lifter, stock cam. One of the other issues with the M8s are these tappet cuffs. Now these are they're to keep the lifter from rotating. All right, so basically when this is bolted up to the case, so let's walk over here to the case. This is bolted to the case here, and then the lifter comes up through the middle. And these little tiny pieces of plastic right here are the only things that keep the lifter rotating. And you can see there's a tremendous amount of play in that. Well, we're not going to trust that. So anytime you do a cam upgrade and you're changing your lifters, absolutely, without question, run the S&S aluminum ones. So again, it does the exact same thing. It's just a much better, much stronger piece. And you can see the lifter, it's a much more precise fit. Okay, and keeps that from rotating around. So that's definitely a bonus there. The next thing, of course, we're doing a throttle body on this one. We're also running our blueprinted injectors. These are going to be 7.1 gram per second injectors for the amount of power that he's going to be putting down. That's going to work out fantastic. So let's continue on to the primary. Of course, we're going to run the Dark Horse Man of War motor sprocket. Again, see the previous video on the Man of War motor sprocket and what it does and why it is so much better than a stock compensator. Now, one of the best reasons to run this motor sprocket is now because we have an absolutely perfect crankshaft. We know it's perfect. So you're going to see an incredible performance out of this and get the most out of it because we're starting with a foundation that we know is going to work well. All right, now to handle all of this, we're going to move over to clutch and clutch basket. Of course, this is the stock clutch basket. And this is a unit from Trask. Now, one of the biggest reasons we want to look at the details and understand why this basket is so much better. Again, it's a CNC machined billet piece, which is much better than cast. See a video on that as well, where we compared the difference between forged, billet and cast pieces, and it kind of falls in line with the cam plates as well. But the details to pay very close attention to is this supporting band that goes around. All right, and you notice how thin it is. Again, it's cast here, and basically your clutch plates fit in these fingers. And then you have in your intermediate plates that engage into the hub. So every time you're hitting, you hit it, you're banging against these, and these fingers, if you will, have a tendency to expand and break. And most of the time when I see a broken clutch basket, it breaks right here and these fingers blow out of it. And that's when everything disintegrates. So not only that, but if you look very closely on the inside here, you can see these marks. Those marks are from the dogs on the clutch plates themselves. So again, this is what keeps those clutch plates from turning, and you can see how rough that is in there. So over time, as this wears more, again making more power, it eats into those fingers in this soft cast material, and the clutch plates will actually start sticking. Okay, or they'll get in there a little crooked and the clutch starts chattering. That type of thing, it's virtually eliminated by using a better aluminum, using billet. So if you compare the two, you can see that band is considerably larger, considerably bigger. Also, you'll notice you don't have the sharp edges that you have in the cast piece. So anytime you have a sharp corner or a sharp edge on anything that's machined, that's a weak point. So Trask made a point to go in here and put a nice radius on all of these, and even the sharp points here. Everything is radiused and everything is beveled all the way around, producing no sharp edges, which again just makes it a much, much stronger piece. So the way that this is installed, this is removed, you retain your ring gear, and this is then bolted onto the back here. And of course this one will also get a Sportsman clutch from Bandit. We would be using an American Prime clutch, Ben Kudon. He doesn't make them yet, so he's working on the M8 clutches, I believe. So but we've chosen the Bandit because it's an absolutely wonderful clutch. We haven't had any issues with them at all. Haven't had any defects at all. It's a great piece. So that's the clutch that's going to go there. And then we're going to be topping this off with a D&D billet cat. We found with our M8s there are several exhaust systems that work fantastic with the M8, but there's something about that D&D billet cat. It really does give a very broad torque range without any peaks or dips. I can't say it's necessarily 100% perfect for your build, but I know that in this combination of all the parts, how we do the heads, how we choose the cams and everything, we are seeing the best consistent results with the D&D billet cat. But there again, if you're trying to fit your build into a particular budget and you already have a nice set of, you know, maybe you've got a set of Reinhardt duals on there, the slim lines. Reinhardt makes a great pipe, and it works very well with our builds as well. So you don't necessarily have to buy a brand new pipe if you already have pipes, because you're getting such a considerable power increase with a build like this. So we're in with a 10.8 to 1 compression ratio, we're going to be in the 140 to 145 horsepower and in a ballpark of 150, 155 in the torque range, making torque exceptionally early and a very flat torque curve. So we're going to have a lot of area under the curve. So thanks for watching, guys. In the next video in this series, we're going to be tearing down a twin cam, and I want to go through all the components in the twin cam as we take it apart, because I believe I can give you a lot of tips and tricks on what to look for during a disassembly, which will help to tell you what you need to do during the reassembly. All too often people just rip an engine apart and go at it, but there are a lot of clues that are hidden inside the wear patterns when you disassemble the factory components that can save you later when you actually do your build. All right, guys, thanks a million. Take care of yourselves and each other. Have a great weekend. See ya.